So I'm going to go over the 2016 to 17 paper, the ICA paper. Okay, so for question one, I'm just going to read out the question where it was. It said that in a year's time, the stock will either be valued at $10 or $35. A certain derivative has a payoff of ST cubed minus ST plus 2. So what I'm going to do is do my usual structure of first making sure that there's a binomial tree, which we could clearly see. So of 10 and 35. And so that we know that if it goes, no, maybe not that way, because I want to make it clear that when it goes up, it's going to 35, and when it goes down, it goes to 10. So for this question, you notice that we don't know the actual stock price currently, so we can't work out an actual. Uh, we can't find out some things, but the question doesn't require that at all. So for question one, A, it says find a replicating portfolio for this derivative today, stating clearly whether each portfolio component is a long or short position. So the main thing you want to start off with is first identifying that uh, we're gonna use the payoff functions thing. So we're gonna put in this value into the payoff function. So 35 cubed minus 35 plus 2, and that will give us our payoff. So I'm just gonna put payoffs in brackets because I just like doing that. So we can distinguish between what's a payoff and what's a the price of the stock. So we're gonna get $42,842, and if it's a and if it went down to $10, we know that the payoff is actually $992. So first of all, we could already tell that we have a strike price of somewhere between 35 and $10. It's a call option because the higher the money, the higher the stock price is, the more money you're making. But that's not what the question is asking. They're asking us to find a replicating portfolio for this derivative today. So what you want to start off by doing to get this approach done is you're gonna figure out that the this is general equations is y times s up plus I think it's x e r t is equal to f up y s d plus x e r t equals f down. Now, what you're gonna do with this is ideally you want to show that we could just plug in these equations. To be honest, what am I talking about? We just plug in these equations. So y is what we're trying to find. So I'm going to highlight what we're trying to find. Y and x. Y represents. I'm just going to delete this because I won't have enough space for this. So y represents shares. So change in shares. To be honest, it's our delta. X is derivatives or bonds, same thing to be honest. And if y is positive or x is positive, then we'll know that we will be buying or longing this position. And if they're negative, if either one of these are negative, then we're going to be shorting wherever it is. So x is commonly negative, meaning that we usually short a derivative. So just to give you some general context before we actually go into solving this problem. And now, to find out, to plug in these equations, I'm just going to write them down now. So y times s up. So we have s up, which is, we know that it will go to 35 times y plus x e, forgot to mention, but the risk-free rate is already mentioned there, is 0.06, and it's at a year's time, so that we'll know that t is equal to 1, so I don't need to write that down. And also, just got to put in that it is equal to 42,842 and 992 pounds for this one. And we know that we have 10y plus x e 0.06. Now we could just cancel them down. We're going to get 25. Sorry. So like a usual simultaneous equation, we could cancel it down. Get 25y is equal to 42,842 pounds minus 992 divided by 25 to give you, hopefully we could get what y is. So 42,842 take away 992 divided by 25 will give you what y is. So since I'm dividing by 25, I skipped a few steps, but let's just write it down. So this calculation gives us that y is equal to $1,674, and this is what y is. So now we've got to find out what x is. So we plug in what y is into one of these equations. It could be this one or it could be this one, doesn't matter. And then we could find out what x is, and x is usually going to be negative, like I said. So let's just try it out and see what we get. I'm just going to work it out over here. I'm just going to take out this because we don't need this anymore. So I forgot to mention this, but for this equation, obviously we're putting the payoffs of each of the binomial cases, the binary cases. So when we plug in what y is into one of these equations, we're going to get x e 0.06 is equal to 42,842 to minus 35 times 1,674. I'm just going to skip a few steps. Sorry, I just can't really write it down properly. Divided by e to 0.06. And this will give us what is x. Now, if I type this into my calculator, we get 42,842 minus 35 times 1674 divided by e to 0.06. And that will give us what x is, which is actually equal to, sorry, just rub this out. X is going to be equal to minus 1,400, 0.907, whatever. So we know that x is negative, y is positive, so that we know that x we're going to short and y we're going to long. So we're going to buy shares and we're going to sell derivatives. So that's essentially how to do replicating portfolio approach, and in particular the question 1A of the ICA in 2016-17. And just before we finish, we wasn't given the initial stock price, so that we cannot find out what the actual portfolio value is. But if we was to find out what the portfolio value is, let me see if I can find an example. Yeah, well, doesn't I can't really remember, but it actually should be y equals s naught times by eta minus rt plus x, I think it is eta minus rt. So s naught times by y, I think it is. But anyways, just to get some clarification on this particular part. I'm pretty sure this is made a mistake here, but that's going to give us our actual portfolio answer. So this is pi to represent the portfolio value. But this wasn't relevant for our question, so I didn't check up the formula, but it should be something along those lines. And that is how to work out the portfolio approach.